Did you know that the most abundant element in the universe, making up nearly 3/4 of all matter, has been practically invisible to us for most of history? I'm talking about hydrogen, a quiet, powerful presence locked inside water, hydrocarbons, and even our own bodies. Only in the last century have we started to unlock its incredible potential to generate clean energy. And one of the most remarkable ways we're doing that is with the hydrogen fuel cell. This simple-sounding device has the potential to power our cars, our homes, and even entire cities with clean electricity. The only thing it produces is pure water. So, how does it actually work? How can a small box turn an invisible gas into usable power? Today, we're going to dive deep into the science of hydrogen fuel cells, from the chemistry at their core to the global movement that's reshaping our energy systems. To understand a fuel cell, first, imagine a battery. A normal battery stores energy in chemicals, and once they're used up, it's dead. A fuel cell, on the other hand, is like a battery that never runs out. As long as you supply it with hydrogen and oxygen, it just keeps generating electricity. The magic behind this is a process called electrochemical conversion. Instead of burning hydrogen, which is inefficient, a fuel cell extracts its energy through a controlled chemical reaction. That's what makes it so clean and powerful. At the heart of every fuel cell is something called a proton exchange membrane, or PEM. This membrane acts as a tiny gatekeeper, letting some particles through while blocking others. Here's how it works. Pure hydrogen gas enters the fuel cell on one side, at the anode. There, a catalyst, usually made of platinum, splits each hydrogen molecule into 2 protons and 2 electrons. The protons are positively charged and small enough to pass right through the membrane to the other side, called the cathode. But the electrons can't get through. They're forced to take the long way around, traveling through an external circuit. And that flow of electrons is what we call electricity. This is the core idea of the fuel cell, creating a controlled pathway for electrons to move, generating a current that can power a motor, light up your home, or charge your phone. Once the electrons finish their journey through the circuit, they meet up with the protons again at the cathode. On that side, oxygen, usually just pulled from the air, is introduced. The protons, electrons, and oxygen atoms all combine to form H2O, water. That's it. That's the only byproduct. No carbon dioxide, no soot, no nasty emissions. Just pure water vapor. In one elegant process, a fuel cell turns hydrogen and oxygen into electricity, heat, and water. The efficiency is incredible. A typical combustion engine wastes about 60 to 70% of its fuel's energy as heat. A fuel cell, however, can convert up to 60% of hydrogen's chemical energy directly into electricity. And if you capture the waste heat, that efficiency can go even higher. This technology is already in our world. The PEM fuel cell is what powers most hydrogen cars and buses today. When you drive a hydrogen vehicle, you're essentially sitting on top of a small, clean power plant. Tanks in the car store compressed hydrogen gas. When you hit the accelerator, hydrogen flows into the fuel cell, mixes with oxygen from the air, and instantly generates electricity to turn the wheels. There's no engine roar, no delay, and zero pollution. Just a little water dripping from the exhaust. To the driver, it feels just like an electric car. But instead of waiting hours to charge a battery, you can refill the hydrogen tanks in just a few minutes. This combo of quick refueling and zero emissions is why fuel cells are so promising for heavy transport like trucks and buses, where heavy batteries and long charging times are a huge problem. Of course, there are different types of fuel cells for different jobs. PEM cells are great for vehicles because they run at low temperatures, but there are also solid oxide fuel cells that operate at very high temperatures, making them perfect for generating power for homes and factories. In fact, one of the earliest types, alkaline fuel cells, even powered the Apollo missions to the moon. They all work on the same basic principle, splitting hydrogen and capturing the flow of electrons as electricity. But this all leads to a crucial question. Where does the hydrogen come from? Right now, most hydrogen is produced from natural gas in a process that releases CO2. This is called gray hydrogen. The real game changer is green hydrogen. This is produced through electrolysis, using electricity to split water into hydrogen and oxygen. And when that electricity comes from renewable sources like solar or wind, the hydrogen becomes a completely clean, zero-emission fuel. This creates a perfect energy loop. Renewable energy can create green hydrogen, and that hydrogen can store the energy for later. When the sun isn't shining or the wind isn't blowing, the hydrogen can be fed into a fuel cell to generate electricity. This combination is transforming how we think about our power grids. Countries like Japan, Germany, and South Korea are already building huge hydrogen ecosystems, from production plants to refueling stations. In Japan, you can even find small fuel cells in homes, providing both electricity and hot water. Meanwhile, here in places like California and across Europe, hydrogen-powered buses and trucks are already on the roads, proving that clean transport can be practical and powerful. Even the aviation industry is looking at hydrogen-powered planes, which could one day eliminate airline emissions entirely. Now, it's not all smooth sailing. Producing green hydrogen is still expensive, and storing it safely requires special infrastructure. Hydrogen molecules are tiny and can leak through materials that would easily contain other gases. But modern hydrogen systems are incredibly safe, with sensors, ventilation, and emergency shutoffs. A lot of the fear around hydrogen is based on old myths, not today's engineering reality. What makes fuel cells so amazing is their versatility. They can be tiny enough to power a drone or massive enough to provide electricity for a factory. They can stabilize our power grids and serve as reliable backup power for hospitals and data centers. When paired with green hydrogen, fuel cells provide the missing piece of the clean energy puzzle: reliable, on-demand, zero-emission power. Let's walk through it one more time. Solar or wind energy powers an electrolyzer, which splits water into hydrogen and oxygen. The hydrogen is stored. When you need power, that hydrogen is fed into a fuel cell. It recombines with oxygen to create electricity, and the only thing left over is water, which can be cycled right back into the system. It's a beautiful, self-sustaining loop. The beauty of generating electricity from hydrogen lies in its elegant simplicity. It's a technology that's both old, dating back to the 1800s, and brand new, refined with 21st century science. Researchers are constantly working on making it cheaper and more efficient. As the costs come down, fuel cells could become as common as solar panels are today. So, the next time you hear about hydrogen fuel cells, think beyond the hype. Think about what they represent: a bridge between chemistry and technology, between innovation and sustainability. From cars that only emit water to buildings powered silently by hydrogen, this technology shows that a clean energy future isn't some distant dream. It's already here, humming quietly, getting ready to change the world. Thanks so much for watching. If you found this journey into the world of hydrogen fascinating, don't forget to like this video and subscribe for more deep dives into the technologies shaping our future. See you in the next one.